carry on with 12.2. Didn't want to make the first video too long in case you get bored and start switching off and start, getting all disruptive and that. So what I'm going to do, I've done John running in the previous video, question 15. I'd rather like question 14. Another one of these little teaser type questions. You've got to think a little bit. Now, Mary has a solid ball which has a mass of 540 grams. So mass of a ball. So here she's got like a little ball there, it's all solid, and its mass is 540 grams. So far so good. This ball is made from a material which has a density of 6 grams per centimetre cubed. Straight away I can work out the volume, but we'll see what the story has to say to us. Mary's little brother drops the ball in their fish tank. Okay, so fish tank. Right, tank, fish, looks a little bit like that perhaps. Very, very accurate as you can see. So there we go, fish tank. Now, drops it into the fish tank. The fish tank is in the shape of a cuboid, okay. And it's 20 by 30 and it's 50 centimeters deep. In other words, this part is actually 50. This part could be the 30. This part could be the 20. Please ignore the fact that the 50 looks an awful lot shorter than the 20 and the 30. It doesn't matter. But what I do know is that it's 50 centimeters deep, and the other two measurements are the length and the width. It doesn't matter. I can see that I have a base area of 30 by 20 there. Right, so what we got here, this little brother is going to throw the ball, splash into there. This has probably already got some water in it, so let me draw some water. This is the water level, and when that water gets splashed by the ball bearing, or I'm assuming it's a ball bearing, I don't know, it's going to fall at the bottom. There it is, glugging down the bottom now. Now when you take up some space with a solid little ball and that sinks along the bottom, the water level is going to rise just a little bit. So I'm trying to work out here the height from there to there that the water will rise due to the ball being splashed into it. Now this is obviously an exaggeration of the storyline, but the yellow level is the level of the water in the tank originally. I presume there's fish in it. It is a fish tank after all. And little ball goes in, splash, everyone gets all upset and the fish get distraught, and the water level rises just a little bit, but I've really exaggerated it just to show the effect of what the ball's going to do. And essentially I've got to calculate that rise in water level. So by how much does the depth of the water in the fish tank rise when the ball is dropped in it? So that's the story. Well, if I throw a ball in there, its volume will take up some space, because that's what volume does, and it will cause the water to rise. So I really do need to work out the volume over here. So density equals mass over volume, so that's the original formula. Write it down, and volume is going to be, therefore, change it over, mass divided by density, substituting mass 540 grams by 6 grams per centimeters cubed. Please note the grams will cancel, leaving me centimeters cubed. It makes sense, doesn't it? So I've got 540 over 6 comes to 90 centimeters cubed of volume. Right, so that's gone in there. Now I've already got a 20 by 30 centimeter base. Now I need to say to myself 30 centimeters by 20 centimeters by a certain extra height when the ball gets thrown in will give me an additional volume of 90 centimeters cubed, right? So there you go, 20 times 30 times a mystery height h will all come to the volume of the ball which just got thrown in, which is 90 centimeters cubed. So I've got here 600 times h is 90 centimeters cubed. So h is going to be 90 over 600. Definitely lose a 0 there. And could grab my calculator. 9 divided by 60, 0.15 centimeters. Alright, so that's okay, but why not call it 1.5 millimeters? Much nicer. Is that alright? That's that. Very nice. Did I get it right? Yes, got it right. Very happy. Right, next one, question 16, deserves its own page. It says here, I'm going to draw a little diagram as well. Let's thicken up this yellow so it stands out better. Right, nice and thick. Right, Sam drives 265 miles from Kendal to Bristol. Well, I know Kendal's north and Bristol's south, so that's my diagram. So Bristol, Kendal, and that's going to be 265 miles, and at an average of 50 miles per gallon. So that's 50 miles per gallon in terms of fuel consumption. He then drives 221 miles from Bristol to Norwich. Well, that's more east, so where did he go from? Kendal to Bristol. So actually Kendal should be up here, really. To make my diagram sensible. Kendal up in the north, Bristol down in the south. Okay, Kendal to Bristol, going that way. There I go. 220 miles from Bristol to Norwich. Well, Norwich is sort of more over East Anglia way, so let's draw a big fat chunky, like Norwich is over here. It's not really, you know, bearings in any way. So 221 miles. How economical were you? We're going 48 miles per gallon. Lovely. He then drives from Norwich back home to Kendal. So we're going from Norwich back to Kendal, and we're home. And that is 278 miles. As you can see, I'm not to scale at all. I'm doing this so I can see what's happening in the story. And at an average of 47 miles per gallon. It's quite an economical car. Alright, now his fuel tank contains 15 gallons. So alright, let's put it down one side there. That's what I can contain. And that's when it's full. Now, 16A asks us, is it possible for Sam to complete this journey on one tank of petrol? If you write down yes, you get no marks. If you write down no, you get no marks, because this is mathematics, not, you know, 50-50, phone a friend, let's have a guess, you know, and just ring my mate and what have you. So let's just do the maths. Go back to regular size pen now. Right, 50 miles per gallon. Let's just take a look. Let's see how many miles I can do here. 265 miles, 50 miles per gallon. Essentially, how many gallons will it take me to do that? If I do the calculation here, I go 265 all over 50. That gives me, let's just take a look here, 265 divided by 50 miles per gallon, and that will take 5.3 gallons. Oh, okay, so 5.3 gallons of petrol by the look of it. Now Bristol up to Norwich, same again. It's going to be 221 miles divided by 48 miles per gallon, and see how many gallons that gives us. So it's 221 divided by 48. That's going to give us 4.6. I'm not going to go 4.0. I'm not going to go 4.604. Leave it like that. That's how many gallons. Gallons. And this one, I'll try and make it fit here. If I have to shift to 15, I will. In fact, I will shift it. Gone, but you'll be back. So I've got 278 miles divided by 48 miles per gallon. Slightly less economical part of the journey of that. Maybe it's going fast, I don't know, in a hurry to get home. So 278, divide that by 47 miles per gallon, and that is I've got to go to 1 or 2 dp here. 5.91 gallons. Question: does he have enough? Is it possible for Sam to complete this journey on one tank of petrol? It is petrol. Let's just add it up then, shall we? We have got 5.3 gallons plus 4.6 gallons plus 5.91. Oh, that's dangerous. 5.91 gallons. So this is all part A, okay? So that's going to give us, do the sums, 5.3 plus 4.6 plus 5.91, say. What have we got here? 15.81. Well, I could have ignored the one, couldn't I? And look, 15.81 gallons. Conclusions, therefore, no, you can't do it. Right, so poor old, what's his name? Sam, okay? He might have to take the bus for the last part of the journey. So what I'm going to do then is do part B. And part B says, what if, oh, here we go. What if all the quantities of petrol found in part A had been given to the nearest whole number? What if all the quantities of petrol found in part A had been given to the nearest whole number. Right. What if all the quantities of petrol, not the petrol consumption, but the petrol? Okay. So nearest whole number. What have I got here then? Let's do B up here. I've got the 5.3 is going to be 5 gallons, isn't it? I've got my 4.6, that'll be 5 gallons as well. And my 5.9, well, that's going to be 6 gallons, isn't it? What have we got all together? 16 gallons. I'm sure you can't see that. So I've got 5 plus 5 plus 6, and we've got 16 gallons. So even if we round it off appropriately, you know, up or down as appropriate, there still won't be enough. So it's still no.